Swayam Prabha. Digital India. Educated India.
So that we'll go back to materials and examine a few more things related to it. What do you see here? What do you see here? Black and white and horizontal lines. Yeah? What do you see here? Black and white again, but not horizontal lines. How do you know it is horizontal? How do you know it is horizontal? Does it look like horizontal? It looks, huh? Wow. If you look at them individually. But how do you prove to somebody else who feels it is not horizontal? Really? All of you believe it is horizontal? Sure, huh? It is not, no. So, how do you prove that it is horizontal? Right? So, I can take the previous one and slide it across, right? Wonderful. Now, I have proved that it is horizontal, right? Our intuition fails. Many times, our intuition fails. This is one such example. The other one is beautiful. You want to see it? You see two colors there with the arrow mark. One is brown, the other is orange, nearly orange, right? That's what our eyes are showing us. So, I am going to pull it out and show you. Again, exactly the same color. Our intuition fails again. So, we cannot rely on our original intuition all the time. What seems obvious may not be true. Couple of you. What you should do is like last time, this per group, this per group. All right. What seems obvious need not be obvious. Yeah. What is this? Silly putty. What is the property of this material? It plastically deforms, correct? Yeah. All right. So, if I take this silly putty, make it into a ball, and I want to spoil this ball, what will I do? Throw it, and it will splash. You want to try it? What seemed obvious is not obvious. You can also do it. I am not tricking your mind. Yeah? That's another property. What you saw right now is another property of this, but we assumed some things. That's why yesterday, you threw it on him. That's why yesterday when I showed you how to break it, I pulled it very fast, right? It becomes stiff. Yeah, the same stiffness is used in terms of making it into a ball. Okay, this is true of many clays, by the way, as long as it is wet enough and doesn't stick to the surface. So, let's say you put a polythene cover or some plastic cover on it and you do the same thing, the result will be the same. Okay, and therefore, we have to be careful when we are told something. As scientists, what do? We did something in the initial, today we did something. When I said the lines are inclined, what did you do? Those lines were not horizontal and you wanted to prove they are horizontal. So what did you do? What did you do? To another example. No, another example will come to. What did we do? Observe, okay. Wanted to tell Manasa, no, they are horizontal. So what did you do? Yeah, but what is that process called? You remember the story that I told you about? Experimenting. Experimenting is an important aspect of ourselves, which who are so-called scientists, right? So what did you do the first time? Horizontal lines? You experimented and showed that it is horizontal. And that orange and brown are actually not orange and brown. What did you do? You pulled it out and showed on the white, right? When I told you this is going to splash the wall, what did you have to do? Okay. You know, Aristotle once said, women have less teeth than men. Oh, what would you do? Exactly. So you will ask your girlfriend or probably mom, sister, open your mouth, let me count. And then you establish that Aristotle was wrong, right? Experiment. I'm telling you this over and over because many times we just take it and parrot it. There is no point in doing that. When I was playing tennis, the top of the net used to tear off. So they would tie it once more, it would tear off in a couple of days. This kept on happening. So one day I took an elastic band, right, and tied it. They said, no, this is very soft, it will not stand, etc., etc. And much to the contrary, it stood for about 3 months, right? Why I am saying this is the intuition fails most of the times. So what should you do? We cannot believe on intuition, right? We can't believe in intuition. So what shall we do? We need to build an intuition which is different, yeah, where experimenting is a part of the whole thing. I'm telling you this because all of you want to be scientists and inventors, and this quality is a very important quality. So can I build intuition in SNT, science and technology? The answer is yes. By experimenting is not only to do with materials. It is also to do with symbols called mathematics. Got it? And the answer is a big yes. So that's basically what I wanted to convey initially. And how do you build this intuition? How do you build this intuition? How do you get the experience? Experimenting and observing. That's all over? For verifying what? Okay. Learn from the mistakes. All right, very good. How many of you know the story of Arjuna and Drona's testing? Drona tested Arjuna. Arjuna and his brothers, the 4 brothers, and the 100 co brothers were learning from Drona. But they all felt that Arjuna was his pet student. They were unhappy about it. Drona wanted to convey to them why it is so. So he said, okay, I'm going to now conduct a test for you. The test was a toy bird was kept at a distance on the branch of a tree. You remember the story? And they were supposed to shoot the arrow into one of the eyes of the bird, right? Of course, it's a toy bird. The story is actually not about that. Of course, Arjuna was the only one who could do this. Why is it that only Arjuna could do it? Yeah, so the story has that part also. So Drona asked, what do you see for every one of them? One of them said a tree and then a branch, etc., etc. The other one said branch, bird. Third one said bird. Like that it went on. When it came to Arjuna's turn, Drona asked the same question and Arjuna said, I see the eye. What else do you see? I see the eye. Right? What do you understand from the story? Focus. One of the things that you need as someone who is going to be a scientist or an inventor is the focus. You may probably spend a week trying to solve a problem and only that problem. Eating, sleeping, etc., etc. By chance if it happens. Alright? Same with Virat Kohli. Practiced, found out what all need to be done as improving his body for strength, etc., etc. He was focused completely on becoming the best batsman in the world. So how do I create the intuition? The first thing that I should look at is, can I do the same thing? How do I do it? When your parent, mom or dad, wanted you to cross the road, she held your hand, looked right, looked left, crossed the road. The second day, you were supposed to cross the road, held your hand, asked you to look at right side and left side and cross the road, and you crossed the road. The third day, mom or dad could not come. And what did you do? You looked right, you looked left, and you crossed the road. Why so? Because it became an intuition for you, right? So there is an intuition that is necessary. Yeah, what did you say? In the US, it's different. Anyway, now the question here is, how do I build the intuition? I practice this over and over. When the SMS messages in my mobile phone were exceedingly large in number, I had to sit down one full day and erase each one of them, right? I thought it's a waste of time sitting for one full day and do this. So I decided, okay, I would do it then and there, and delete it. So you can look at my mobile phone even today. It has only 2 or 3 messages, the recent ones or the important ones, because it has become a habit for me to see it and delete it, see it and delete it, see it and delete it. I don't know how many of you do this, but I'm saying this is a habit that got created. So if you are able to create a habit, practice whatever will help you in terms of being an inventor, you can become an inventor. So far, okay? Any questions? So, I am going to introduce to you 3 habits that you can use powerfully in terms of becoming an inventor. Okay? You ready? Ready to play also? Yeah? Okay. Let's play. Of course, here it's not a bench. So, a group of 3 is a team. So, arrange yourself in such a way that 3 of you is a team. Go ahead, fast. 4 of you are there. Only 3. 3. Fast, 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 fast. 3 of you. 3 of you make a team. 3 only. 3. Search. What's your name? Akash. Anant. Search for the other 2. Search for the other. Get up. Yeah. Search for the other 2. What happened? How about him? Okay. So, teams of 3 are formed. Yeah. Quickly. We'll do this quickly so that we can complete this. Okay. Here goes the play. Just close the magnetic ball. Put it in the box so that you can play this right now. So, I'll tell you the play 3 rounds, okay. Player 1 mentions something. It could be an object or an event, alright. So, event could be something that happens, let's say, that you see, notice or know about, okay. So far, okay. Player 1 does that. Player 2, Sanika, is for that object or event, what is the purpose of the object and what is coming into the object and what is getting out. Alright. For example, what is coming into this and what is getting out of this, right. So, you will do this for the object or the event that the first player mentions. Player 3 has a little tougher job. What's the scientific principle behind sound now amplified and going as electromagnetic wave, right? Yeah. If you don't know, what will you do? If you don't know the scientific principle, remember we are creating habit. Google it, find out an answer. By doing this, what happens is you learn that scientific concept. Yeah, that's the idea. And then once you are done with that, 1 round is over, second player starts, another round is over, third player starts, and go. Start. First decide who is number 1, number 2, number 3. Not magnetic. Magnetic, there is one more. Who is player 2? Folks, when I say statue, you will just stop, alright, so that we can communicate. Continue. Statue. How many teams have not finished 3 rounds? Raise your hand. Not yet. Oh, no, 1 round implies 1 player. So, 3 players have completed means the 1 round is over. Anybody who has not, any team that has not completed 1 round, which means that 1, 2 and 3 players have participated in guessing a particular object. Done, no? Okay. Because for want of time, I just thought we would proceed further. This is a habit. If you are having a set of friends with you, you can play this game, right? But sometimes you may not have the friend. So what will you do? all by yourself, all three players by yourself. Correct. So you can guess an object. Okay, switch. All right. Okay, switch. Search. What is in? What is out? Right. And then what's the scientific principle behind it? Over. Right. Keep doing this over and over. Some you may not be able to answer. Google it. Find out. Right. Thereby you are at it all the time. Yeah, folks. Yeah. We'll go to the next game. Yeah. Before that, so that's the individual exercise. List as many objects. You can even use your notebook. You have your inventor's notebook. Really, have your inventor's notebook. It could be on your mobile also, no problem. Have an inventor's notebook. Keep writing. All right. You want to be an inventor, no? That's why. And therefore, you observe something, you connect to what is happening in that object, have that curiosity over and over as the first trait one should have as far as inventor is concerned. Okay. So you'll ask this question: what, how, and then why. So this is habit 1. Okay. See, observe, understood. What, how, why. Okay. Let's go to habit 2. Anyway, you can also do this, but let's see. This is the second game. This is to do with yellow hat. I don't know if you have done 6 hats here. Yellow hat represents positive hat. What is positive about that? What is positive about this? What is positive about this? I don't have to go to this, right? That's the positive, right? What is negative about this? Consume electricity, all those, right? So you know what is yellow. So when you wear the yellow hat, you look at positives of that. When you wear the black hat, you look at only caution, negatives, etc., etc. All right. When you wear the green hat, green hat is an idea hat. So you'll come up with an idea. It could be followed by white, yellow, or black. White is information. What do I know? What I need to know. What do I know about this? It's an electronic. What do I need to know about this? What it can do. All right. And forget about the other 2 hats. May not be important right now. But just wanted to give you an idea of the hats here. Okay. So same teams. All right. If you want to switch, you switch it now. Player 1 mentions an object. Same thing. Okay. Player 2 imagines the object that existed before this object. What existed before this object? You need to go and press, or probably a wired one, right? What happened? Yeah. All right. So imagine what existed before this? Right. What existed before this? Knife. Right. So what existed before this? That's what I tried initially, right? Player 3 will ask what was the yellow or black hat about it. Yellow hat could be the current one, black hat could be the previous one. Okay. Did you understand this game? Yeah. The last one is what was the yellow hat or black hat that led to the current one. Why am I having this instead of the wired one? Right? That's what you will explain. All right, you will guess. If you don't know, again you will Google it, find out. Now, for example, how many of you love coffee? Many of you love coffee, correct? Now, where do you go and have coffee? In my days, it used to be a restaurant, it used to be some tea cafe and so on. But today, somebody looked at the positive of it and came up with Starbucks, coffee day, because you can also sit down and relaxedly chat, correct? So looked at something that could exist and created it. So invented it. And that's what is the last one. It could be yellow, it could be black, usually black. Okay? Clear about this? Huh? Start the game. By the way, player 3 also will give that idea that led to this. Idea that led to this instead of a carded one. Got it? Player 3 will give both these. Right, Ananya? Getting bored? Okay. We'll make it interesting in the next habit. Start now. Any of you who have not completed, any team that has not completed one round? Wonderful. All of you have completed. Okay. We'll go to the next game, but before that, just a view of what has happened. There's a lot of material available on the history of something. All right. It doesn't matter whether it is history of bench, whatever object, history of glasses, everything has some history to it. History gives you an idea of what ideas the inventors got. That's very important for you to build that kind of muscle, right? You see a bodybuilder and you want to build muscles, right? Want to go and find out from that bodybuilder what he or she did, correct? And that's what is important. So here we have a mouse that we use nowadays, correct? What existed before that? Corded mouse, correct? Cordless mouse is what you're using right now, right? Corded mouse existed, right? Before corded mouse, ball mouse, right? Where there were two balls which were moving. So you have X and Y axis so that you can explore the entire screen. Before that, right? Now we'll go forward. They had this rolling mouse. Why did they change it? Don't answer. Don't answer. But this is a question that arises in the mind, correct? And then you explore the answer. When you explore the answer, you get an idea, oh, okay, this is what the inventor could have found out. Okay, this is a very important exercise for you to do. Doesn't matter what that object is, go back and find out. Clock is a fantastic example, how it evolved. Let's just watch this before we proceed.
It turns out that the concept of using something other than those clunky arrow keys to move a cursor around predates the modern mouse by several decades. I'm talking about the trackball, which sprang into existence all the way back in 1946 as part of a British Navy project to help track aircraft on radar. This concept was later adapted by the Canadian Navy for their own tracking system, which used a small 5-pin bowling ball, of all things, for the ball, because presumably they couldn't get funding for a real one. These early implementations were rather crude, with the ball placed on top of spinning metal discs that came into contact with wires. But because the UK considered it a military secret, the idea of using a spinning or rolling object as a computer input device wouldn't end up being realized in the civilian world until years later, when the first true mouse was invented in 1964 at Stanford University. Now, unlike modern mice, which have total freedom of movement in one plane, this early mouse only had two pizza cutter-looking wheels that allowed movement up and down or side to side, but not at the same time. The inventors decided to call their creation a mouse because the wire sticking out of the end looked like a rodent's tail, and they used it in conjunction with the NLS, a DARPA-funded computer system that included clickable hyperlinks. Remember, this was nearly 30 years before the internet started becoming widespread. Soon after that, the mouse was picked up by Xerox, who developed a personal computer called the Alto in 1973, which used an actual graphical user interface complete with mouse support. And Xerox was actually also developing ball mice while they worked on the Alto, which would allow users to move the mouse in any direction they pleased. These worked by keeping the ball in contact with axles attached to wheels with holes in them. As the mouse moved, the axles would turn the wheels, causing beams of light to repeatedly break into pulses, which hit sensors that registered which way the mouse was moving. This design revolutionized the way we interact with our computers. Aside from changes in ergonomics, which gave mice a shape more suited to the hand than that original plastic brick form, the basic way that they worked didn't really change between the mid-80s and the mid-90s. So users of external mice had to wait until 1966 for the first widespread mouse with a scroll wheel. Even though that concept had actually been realized back in 1985 with the Mighty Mouse, featuring a wheel on the side instead of the top that you controlled with your thumb. Then the late 90s also brought an even bigger sea change, optical mice. Like the scroll wheel mouse, the optical mouse was first developed long before it hit the market. In fact, early versions that used specific tracking surfaces were actually invented back in 1980, when even ball mice were relatively unknown. But development of optical mice that could work with generic surfaces like mouse pads, tabletops, or your pants didn't happen until much later. And it also took a while for component costs to come down to the point where they were cheap enough to mass produce. The upsides to optical mice included not only more accurate tracking than with a ball mouse, but also better reliability. The optical sensors, which worked by taking many photos of the surface that the mouse sat on every second and then sending them to a chip that would process those images to detect movement, were much more resistant to the dirt and gunk that all too often fouled up mouse balls and degraded performance. Later, in 2004, Logitech released a frickin' laser mouse, which would not only incinerate your enemies, but also sport even more accurate tracking thanks to the use of a laser beam which could see surfaces under the mouse with more precision than standard LEDs. This was a boon for more serious PC gamers that wanted the more granular tracking during the heat of battle. Now, there have been other improvements to mice in recent years, but they mostly come in the form of adding more general technologies to mice to make them more versatile, like replacing PS2 with USB, which you can learn about here, implementing scroll wheels that can switch between smooth or clicky operation, adding wireless data, and even charging support, peppering them with programmable macro buttons, adding the ability to track on glass by scanning for small scratches and dust particles, and of course, covering them with the oh-so-important RGB lighting that you know that you crave.
Chocolate question. What's the future? Why? Why would I go back? Good point, but why would I go back? See, today, this Ponniyin Selvan, no? Ponniyin Selvan used to come on a magazine called Kalki when I was about your age, perhaps a little bit younger, 10th standard. So every week I would wait for this Kalki to arrive so that I could read that Ponniyin Selvan novel. Today, how many of you watched Ponniyin Selvan? So many, no? That's what he is talking about. But yeah, go ahead. Expand. Okay, correct. So going back always helps. So I give it to both of you. One of the things that happened recently is we have been using alternating current. Why? Easier to transmit. Tesla found it out, and we are using it over and over. But today, with the advent of solar energy, which is distributed in nature, this AC current is not as useful as DC current. So now they go back and look at, okay, can I make this an AC motor, right? So now they are going back and reinventing the wheel. It is always important to go back and reinvent the wheel, because perhaps you may end up with a square wheel. IR or VR, whatever glasses, virtual glasses, and then do the tracking. All right, very good, nice. Such thoughts are very important because that promotes your capability to invent. No no thought that you have expressed is bad or good. It is just that you have to explore it. Yeah, actually, they have already started it out. I think there is a Caltech team which has already implanted in the monkey brain and has conducted this. There's a lot of research that is going on in brain research, brain device research also, right? So it's not far from today that we will see this kind of a thing happening.